All right, geometry, section 6.5, conditions for rhombuses, rectangles, and squares. So this section is just presenting what are the converses to 6.4. So it's the converse of section 6.4. So again, we're going to be given a parallelogram. We want to show that it is a rhombus, rectangle, or square. So there is a condition that must be met. So let's talk about those conditions. Okay, so for these two ideas, we're talking about making a parallelogram. So we know it's a parallelogram. We want it to be a rhombus. So in most cases, you're going to need to show that two consecutive sides are congruent, like A, B, and B, C. You'll be given that in the first one, the diagonals are perpendicular. That's going to help you prove this idea. In the second idea, you're going to be given that a diagonal bisects a pair of opposite angles, meaning that these two angles are congruent and these two angles are congruent. So through this, that should be enough to help you prove that these are rhombuses, in fact, rhombuses. This last idea is about a rectangle. So now we know that it's a parallelogram. We want to prove that it's a rectangle. So to prove something is a rectangle, you have to show right angles, right? And typically just one. If you show one of the corner angles as a right angle, you should be good. So in these proofs, you'll be given the diagonals A, C, and BD are congruent. All right, cool. All right, so I'm going to do one proof involving one of these ideas. All right, so here's the proof I've chosen for us. So we're going to be given ABCD as a parallelogram, and that AC bisects BCD, okay? And we want to prove that AB is congruent to BC. So this is the idea, right? This is the idea of a rhombus, right? If AB and BC are congruent, then we're going to have a rhombus. So this is, start with a parallelogram. We have a diagonal bisect. Now they just bisect one of the corner angles. We'll talk about why in a second. So we need to prove that AB and BC are congruent. Okay, so here's how we're going to do this. So we're going to first start with this idea of AC and AC bisecting BCD. So if AC bisects BCD, then these two angles are congruent. So BCA and DCA, they're congruent, okay? Then we're going to use the fact that we have opposite sides being parallel because it is a parallelogram. We know that this and this are parallel lines. AC is my transversal. So alternate interior angles, these two angles down here are going to be the same as those two up there. And now what I've done is I've created a situation where I have an isosceles triangle. I have two base angles congruent, which means that the opposite sides will be congruent, and that's going to be enough to prove that this is a rhombus. So this does not involve no congruent triangles, which is one of the very first proofs that we've done that doesn't involve congruent triangles. No congruent triangles. Okay, so most of them do, but this one is not going to. Okay, all right, so let's take a look at it. All right, so again, the first thing I'm going to do is talk about the angles here at BCD. So I'm going to say that angle BCA is congruent to DCA, and that's because of this angle bisector. An angle bisector divides an angle into two congruent angles. Good. Okay. Now I'm going to use again the fact that opposite sides are parallel. So I'm going to say this first, right? I'm going to say that BC is parallel to AD. And again, let's see if I need to say that. Opposite sides of a parallel are parallel. So it seems like they want you to state the idea first before you use it. Okay. And now I'm going to prove that okay, that this angle is congruent to this angle. And I actually used, if you look, I used the wrong pair of parallel sides. So I'm going to show you I made a mistake, right? I made a mistake because I want to use these two angles, which would mean I have to use this parallel side and this parallel side. So A, B, and C, D. So this, I'm not going to use. I'm actually going to replace it. So it thinks it's there, but I know a lot of you guys do proofs and you you throw a step that you don't need. So let's do the other pair of parallel sides, AB and CD. So sorry about that mix up, right? So now I'm going to use AC as my transversal, and now I'll be able to say that angle, I'll say DCA is congruent to BAC. DCA is congruent to BAC. And that's going to be because they're all triangles. This N, this upside down N, is just like a Z. So lines parallel, alternate triangles congruent. Okay, nice. So now I have all three angles congruent. I need to combine these two steps right here. These two both involve DCA. So that means that angle BCA and angle BAC are congruent. BCA and BAC are congruent. That's the two angles in that top left triangle. So that's my next statement. Angle BCA is congruent to BAC. That is going to be by the transitive property, right? We're going to transition through DCA. And if those two angles are congruent, then again, triangle BAC is isosceles, and those opposite sides, which are AB and BC, are congruent. And this is going to be in a triangle, sides opposite of congruent angles are congruent. And there we go. This is exactly what I want to prove, and I'm good to go. So use the proofs from 6.4 to help you with these proofs in 6.5. And again, I'm here to help too. Okay, just do your best. All right, best of luck.